Hey guys, sorry for the late video, but I'm just going to run through I'm just going to explain my solutions instead of working them out for you, so we can make it just a short video in case you have any questions. Okay, all this stuff up here first, I have the distance formula and the midpoint formula, distance from 2,1, midpoint from 2,2, and then those steps for finding a point that partitions a directed line segment into a given ratio. That's the stuff from point 2.3. So you remember, if you're using that formula, I'll write that down for you real quick, is it's the coordinates. Let's see, if your ratio is represented by the letter k, then you'll have that k multiplied by your run, which is x2 minus x1. Then remember, our next step was to add that to the initial point x1. All right, that altogether gives you your x coordinate of that point. Pretty similar thing for the y's, k times y2 minus y1. Then you add that to y1. That together and all in one step, all in one big formula that you don't necessarily need to remember, but that can give you your points that you need as well. Okay, so let's go. Number one, which expression represents the distance between points M and MN and PQ? Okay, distance formula. Obviously C can be thrown out because it doesn't look like the distance formula. It's two separate things. And then we look for the one, our 2 points have x coordinates M and P, so we'll look for the one that subtracts M and P. And the only one that does that, that's not C, is D. Okay, and it works out as well. You look at the N and the Q; those are your y coordinates, and you subtract them and square them. And that's all our distance formula is telling us to do. Number 2, a segment has endpoints L -2, 7 and K 5, -3. What are the coordinates of the midpoint of LK? And I just noticed that it's asking for the coordinates of the midpoint, and my solutions are wrong. Right? So if I want to find the coordinate of the midpoint, so this is a prime example, people, of why you need to read the question and don't go too quickly through it like I did. Okay, so the midpoint, it's a completely different formula. It's this one right here. So we just add up the x's, add up the y's, divide by 2 each time, and that gives you the new coordinates. So m equal, let's see, -2 plus 5 over 2, 7, plus the -3, we can say is just -3 over 2. Okay, simplify now. That's all you got to do. -2 plus 5 is 3. Then divided by 2 is going to give me, let's see, I'll write it out for you. And this is 4 over 2. Now we can simplify this to 1.5, comma 2. And that's our answer. So that's the midpoint of the segment LK that has endpoints those 2 points. Find the distance between, number 3, find the distance between -8 and -2, -8, -2, and 6, -1. Just plug into the distance formula. So -8 minus your 6, we have that right, we square it. Then we have the -2 minus a negative, which is just +1. Okay, squaring it. -8 minus 6 is -14 squared, and this is going to be -1 squared. So 196 is 14 squared plus 1. You get the square root of 197, so which is approximately 14.04. Okay, decimals are fine. Round to 2 decimal places. Find the distance between -4, 5 and 4, 0. Just plugging into the distance formula again. -4 minus 4, those are our 2 x's. Subtract them, square it. 5 minus 0, same thing. Okay, -8 squared is going to give me positive 64. 5 squared is 25. Together they give me square root of 89, which is approximately 9.43 to 2 decimal places. Okay, GH, so what we could have done, there's 2 possible ways to find this one. You could have just find the 2 coordinates, so, and plug into the distance formula. So if the 2 coordinates, just to make sure, are H is 0, 3, and G was -2, -3. Okay, what I did was I set up a right triangle and used the Pythagorean theorem, which of course is the a squared plus b squared equals the hypotenuse squared, which is what we're trying to find. So 2 squared plus 6 squared, that's 4 plus 36 to give me 40. Square root both sides to get rid of the squared on the left. You get it. Square root of 40 is approximately, that simplifies to 2 square roots of 10, and that is approximately 6.32. You could just plug these 2 coordinates into the distance formula as well if you want to do that way. Okay. Number 5, if M is the midpoint of segment XY, find the coordinates of X if M has coordinates -3, -1. So this is my midpoint. and y has coordinates -8 and 6. So I know the midpoint and I know one of my endpoint coordinates. So I let my other one be, let x, let's say be x. Call point capital X, let it be just what? Little x, little y. I don't know it, so generally x represents the x coordinate of it, y would represent the y, okay? We're going to end up solving equations to find these. So I take my two endpoints, x and y, what I have for them, plug what I have into the midpoint formula, okay? 8 plus x plus -8 is this x minus 8 over 2. Y plus 6 over 2 is where I got there. And this midpoint, since this is the midpoint formula, it's representing what my midpoint is. But I do know what my midpoint is. It's -3, 1. So this allows me to set up an equation to solve for those two missing coordinates I'm trying to find. Okay, so that means we set the x coordinate to the x coordinate, which is what we've done here. We want to get rid of that 2 in the denominator, so we multiply both sides by 2, and that results in just the the 2's will cancel out, right? And then we're just left with x minus 8 on the left, and then on the right, -3 times 2, of course, is -6. Solving this again, add 8 to both sides, you find that x is equal to 2. Okay? Do the same thing for the y's. Y plus 6 over 2 is equal to this -1 now. Multiply both sides by 2. Y plus 6 is equal to -2. And then subtract the 6, you get y is equal to -8. So my point x has the coordinates 2, -8. And then we're doing the same thing for these next two right here, right? X plus, so let's see, my midpoint is -1, 2, so that's why it's right here. My one endpoint I do know is 3, -5, and then I call the other B, I call A, x, y again. X plus 3 over 2, y plus -5, which is y minus 5 over 2, that's going to equal -1, 2. Set them to the x is equal, set the y coordinates equal, and solve. Okay, so solving this down, if we follow my steps here, I get x is -5, again over here, my second equation, multiplying both sides by 2, subtracting 5, you get y is -1, so my coordinate of the other endpoint A is -5, -1. Again, doing the same thing one more time, okay? Follow the same process for that, okay? So look, I end up my midpoint is -5, 10. That's why it's on the right side. -8, 6 is the one of the endpoints, so x minus 8 over 2 would represent the x with the missing endpoint in there, and then y plus 6 over 2. Solving, we get this equation: x minus 8 over 2 equals -5. Multiply both sides by 2. X minus 8 is equal to -10 now. And then add 8 to both sides, you're left with x is equal to -2. So for the y, we have y plus 6 over 2 is equal to 10. Multiply both sides by 2 to get that y plus 6 is 20, and then subtract that 6 to get that y is 14. So my other endpoint J has the coordinates -2, 14. You will have one like this, I guarantee it, on the test, okay? So know how to do that. I gave you three problems for you to see different examples from. Number 8, in the diagram shown left, points S and T are the midpoints of PQ and PR respectively. Okay, so I've got this little triangle looking thing, and I have PQ and PR. S is the midpoint of PQ, and T is the midpoint of PR. First, it wants us to find the coordinates of points S and T. Okay. To find S, we'll start with that one. We're just trying to find the midpoint, use the midpoint formula on P and Q. Okay, so the x coordinates, 4 plus -2 is 4 minus 2 over 2. 7 plus -3 is 7 minus 3 over 2. We simplify now, we get 2 over 2 and 4 over 2, which then simplifies further to find that S has coordinates 1, 2. Right, which you can see from the graph, right? You could have just looked at the graph. However, we practice on the midpoint, okay? When I do my midpoint formula, I should get for T, I should get what? 5, 5. No, 7, 5, excuse me. I should get 7, 5, because this is 6 and 7, and then up 5 right here. So 7, 5. Let's see if we get that. Of course we do, so let's look at it. we're looking at P and R this time. All 4 and 10 are the x coordinates of those. Add them up, divide by 2. It's 14 divided by 2, which gives me 7. 7 plus 3 are the y coordinates. Add them up, divide by 2, you get 10, and then divided by 2 is now 5, which is what we wanted. Find the length of ST. So S and T, we have their coordinates now. We just found them. To find the length of ST, that's just the distance between the distance between those 2 points. So we use the distance formula when we're trying to find distances or lengths. Alright, so ST, remember we write those as the segment name without the line over the top. So ST is equal to, and we plug into the distance formula. So subtract the x's, 7 minus 1 squared. Subtract the y's, 5 minus 2, square it. So this is 6 squared and 3 squared, which is 36 plus 9, square root of 45. That simplifies to 3 square roots of 5. Calculator will do that for you. I can explain that another time. We'll do square roots another day, okay? So 3 simplifies to 3 square roots of 5, and then that's approximately 6.71. Alright, there we go. Number 9. Given points A, has coordinates 2, 5, B, 0, 0, and C, 4, 2. Find the coordinates of M, which is the midpoint of BC. Okay. If M is the midpoint of BC, you use these two and plug into the midpoint formula. So 0 plus 4 divided by 2 would give me my x. 0 plus 2 divided by 2 would give me the y. We're simplifying now. 4 over 2 simplifies to 2 for that. Then we get 2 over 2, which now simplifies to 1. So M has coordinates 2, 1. Okay. Which of the points B, M, or C is closest to point A? Alright. The word close, that just kind of implies that I'm dealing with how far away, or the distance between each of these points and A, and see which one. If it's going to be the closest point, it means it's going to be the one with the least distance between the 2 points, correct? So that means I'm going to need to find BA, MA, and CA. Right? We're plugging into the distance formula with B and A, then with M and A, and then with C and A. Once I do that, I see which one is the smallest number, and that would tell me which 2 points are closest. Alright, so we did the first one right here, BA, plugging those 2 points into the formula. B has coordinates 0, 0. This one should be easy. A has coordinates 2, 5. So 2 minus 0 squared plus 5 minus 0 squared just gives me 2 squared plus 5 squared, which is 4 plus 25, square root of 29, which is approximately 5.39. MA. Now M, we found the coordinates to be 2, 1 here. So A still has coordinates 2, 5, so we subtract those. 2 minus 2 squared plus 5 minus 1 squared. These are going to go to 0 on the x's because 2 minus 2 is 0. So we're just left with 4 squared. Take the square root of that, you just got 4. Okay, CA. So C is 4, 2. So let's see that. 4 minus 2 squared plus 2 minus 5 squared. That's a 2 squared plus a negative 3 squared. So it's 4 plus a 9, which is the square root of 13, which is approximately just 3.61. So this is the smallest number, 3.61, which is the distance between C and A. So since that's the smallest number, C is closest to A. Alright, move on to the back. Which expression represents the midpoint of the line segment X, Y, and PQ? Okay, plug those into your formula. That's all I want you to do. So our X coordinates are X and P. X plus P divided by 2. The only one that has X plus P divided by 2 is C. I can stop there. I don't even have to check the Y's. They're going to be correct because there ain't nothing else. Alright, so stop there, it's C. For the coordinates 5, 8, and 9, 14, one is an endpoint of a line segment and the other is a midpoint. How many possibilities are there for the other endpoint? Okay, so think about it this way. If I have I'm on a line segment, if I have a point and a point, okay? If one is say this is the endpoint and this is the midpoint, okay? To go to the other endpoint, you're going to have to go in that same direction, right? Because a line segment is straight, and you go the same distance the other way, right? Okay. However, what I can do the stuff we were doing up here. Right? Pick one to be your endpoint, pick one to be your midpoint, and find the other endpoint using this stuff from 5, 6, and 7 that we've done. That's what I did. Okay, so I did call the other endpoint x, y, so I just plugged in x plus 5 over 2, y plus 8 over 2, and that's going to be equal to what we let the midpoint be, 9, 14. Okay. All right, and then we solved that same way we did this stuff, and I got that x is equal to 13, and y could be equal to 20. 13, 20. Okay, so that's one possible. There's only one other possible way it could be. Okay, so if I erase this right here, what if now I erase this and I let this one be the, say, endpoint, and this one was the midpoint? The only other way I could go is this way, right? And I'd find something, the other one in the other direction, and that's what we're doing here. Now we just choose the other point, and now we chose the endpoint first time to be 5, 8. We'll choose 9, 14 to be the endpoint, and the midpoint we'll choose to be 5, 8. Now x plus 9 over 2, y plus 14 over 2 is equal to the midpoint we've chosen now to be 5, 8, and then solve. Okay, and we get x to be to 1, and then solve the other one. You get x as y is 2, so it could be either 1, 2, or 13, 20. My little example I did was not accurate based on the points. Okay, I wasn't trying to. I was just kind of trying to show a visualization of what the process we were taking. Okay, only 2 points here, and then we got it. We explained your method. I just explained it. My work pretty much explains it, but also I explained it in words to you. Okay. The coordinates of the vertices of a triangle are D5, 6, E7, 5, and F4, 3. Find the perimeter of the triangle. Remember, if I have a triangle, D, E, F, triangles have 3 sides. Okay. Those 3 sides are DE, which is that one. Excuse me, I'm having a little problem here. We got D, E. This side would be what? E, F. And then this side would be D, F. Okay? Find the length of them. If they're plotted on a coordinate plane, we have their coordinates. To find DF, or to find DE, you would just plug in the coordinates into the distance formula. Once we found the 3 lengths, we are going to add them up, because that is what perimeter is. It's the sum all the way around the shape, which is the sum of the lengths of all 3 sides. Okay, so DE, assuming I did this correctly, and I already found me a mistake here. Oh my goodness. Okay, so let's correct my mistake while I'm here. All right, this should be 7 minus 5 squared. All right, and then 5 minus 6 squared. So this will not be, instead of 5, this will be 2 squared plus 1 squared. This will be 4 plus 1, which is the square root of 5, not the square root of 26. So, hey Siri, what is the square root of 5?
The square root of 5 is the positive real number that, when multiplied by itself, gives the prime number 5.
Hey Siri,
do you want me to keep reading?
Hey Siri, what is the decimal value for the square root of 5?
I found an answer. It's displayed on your iPhone.
Okay. Okay, it tells me that it is 2.23. Man, that usually works. 2.23. Okay. Next, we'll take, we're trying EF now, so 7 minus 4 squared plus 5 minus 3 squared. Okay, I set this one up correct, thank goodness. So 3 squared plus 2 squared, this is 9 plus 4, square root 13, which comes out to be approximately 3.61. Okay, now let's check DF. 5 minus 4 squared, that's right. 6 minus 3 squared, okay, I got that one right too. So all of these, so that gives me 1 squared plus 3 squared, which is 1 plus 9, which is the square root of 10, which is approximately 3.16. So I fixed my perimeter now. We'll get a different answer than what I have in my solutions. I'm sorry, I'm human, people, I make mistakes. So 2.23 plus 3.61 plus 3.16 is going to give me 9. Oh, that's a much better answer. Awesome. So our perimeter is 9. Cut. You will have one like this on the test, okay? Just be ready. If I gave you a rectangle, you don't have to think about it. You don't have to. Anyway, I'm not gonna ruin it for you. Okay. The HHS girls soccer team hosts a walk as a fundraiser. The walk follows Bell Avenue, which we don't have a Bell Avenue in software, but bear with me. The picture had it all in there. So the walk follows Bell Avenue from point B to point C, shown on the map. Okay. What is the distance in kilometers from point B to point C? Plug into the distance formula using those points. 9 minus 1 are my x-coordinates of the 2 points. 9 and 1, so 9 minus 1 squared plus 10 minus 4 squared. So that's 8 squared plus 6 squared. That's 64 plus 36, which gives me 100, and I know the square root of 100 is 10. So the distance of this portion of the walk along Bell Avenue is 10 kilometers. Okay, now, a water station is located at the midpoint of M of BC. Then you got another water station locating at the midpoint N of MC. So basically we're going like this, right? This is B, C, in the middle, I've got M, okay? That's one water station. And then between M and C, there's one at the midpoint of that N. Alright? A race coordinator says that the map coordinates of point N are 6, 8. Is the race coordinator correct? And then support your answer. So what we got to do first, before I can do anything remotely wanting to know about point N. Point N is found by using point M, and we don't even know point M, so we need to find that first. Okay, where B has coordinates 1, 4, C has coordinates 9, 10. So since M is the midpoint of those two, we'll find it using the midpoint formula. 9 plus 1 divided by 2. Those are my x's. 10 plus 4 are my y's. Do that divided by 2. You get 10 over 2 and 14 over 2, which is 5, 7. Okay, so found N. Now, this race coordinator person tells us that N, he thinks that it has coordinates 6, 8. We're going to check his work, okay, by doing it ourselves. When in doubt, don't ever trust in what anyone tells you. Do it yourself. Make sure you got it right, because people oftentimes are not right. Anyway, back to this. N is the midpoint of MC, so find N and check. So N, you use the 9 from C and then 5 from M to get 9 plus 5 over 2, and then 10 plus 7 over 2. I can already tell that it's not going to be the same, because this is going to be an odd number and it's going to be a decimal. But anyway, we'll continue on. 9 plus 5 is 14, then over 2. 10 plus 7 is 17 over 2. But they simplify to give me 7, 8.5, which is not 6, 8. So the race coordinator is wrong. See, don't trust what someone tells you. Do it yourself. Alright, now, we've got a partitioning stuff here. Here we go. Given directed line segment AB, find that the coordinates of P such that the ratio AP to AB is 4 to 5. Plot point P. So, I know this is a part to whole ratio already because it's a part which is AP to the whole thing AB, because my segment is AB. Okay. I write down my coordinates. A has negative 8, 2. B is 7 minus 3. And we solve. My first step was to do my ratio as a fraction, which is just 4 to 5 over 5. So let's find the run. 7 minus negative 8, which is just a 7 plus 8. It's going to equal 15. Okay. Now we multiply that 15 times the ratio of 4/5. Okay. 15 divided by 5 is 3 times 4 is 12. We add that number now to our initial x coordinate, A, which is negative 8. So 12 plus negative 8, it gives me a 4 for the x coordinate. For my rise, I do negative 3 minus 2, which is a negative 5. Multiply that by the 4/5 ratio. The 5's cancel out, and you're left with a negative 4. Okay, and then we add that negative 4 to the y1, which is 2. And we get that y of point P is negative 2. So P has coordinates 4, negative 2. And you can see that plotted on my graph over there. Moving on to number 15, we're given the directed line segment WV. We want to find the coordinates of R such that the ratio of WR to RV. Okay, this is a part-to-part ratio now, because WV is nowhere to be found in there. is 3 to 4. Plot the point R. So W has coordinates -4, -6. V has coordinates 3, 8. W is my initial point because the way of the segment is written as WV. The ratio is not a part to whole ratio, so the part to whole ratio, add up the 3 and the 4, that gives me my whole, the amount of parts of the whole, which is 7, and then my part from the beginning was 3, so 3 over 7. Okay, we'll use that to solve it now. So find your run. That's going to be 3 minus a -4, which is just 3 plus 4, gives me 7. So you take that, multiply by the ratio of 3/7. 7s will cancel, and you're just left with 3. Okay, add that to your initial x-coordinate of -4 to get that the x-coordinate of point R is -1. Now, moving on to the y, find the rise first by doing 8 minus a -6, which is the same thing as 8 plus 6. That gives me 14. Okay, multiply that 14 times the ratio of 3/7. 14 divided 7 is 2, and then take that and multiply by 3, which is the numerator, and you're left with 6. Okay, add that 6 to the y1, the initial y-coordinate, which is -6. 6 plus -6 is 0, so my y-coordinate of point R is 0, and we graph that, and of course it's on the segment right where we want it to be. Okay. Number 16, point S lies along the direct line segment from A20 to R64. Point S partitions the line segment into 2 parts with a ratio of 1 to 3. Okay? It's partitioning into 2 different parts. Okay? So the 2 parts have has the ratio 1. One represents 1 part. The other part has 3 in it. So together they have 4 parts altogether. So our part to whole ratio is 1 to 4. Okay, we now look to find our run. We're going from A to R, so A is our initial point, and R is our stop point, our terminal point. So to find our run, you take the R minus the A. 6 minus 2 gives me the 4. Multiply by the ratio of 1/4 to get that 1, and now we're adding that to our x-coordinate of point A, which is 2. We get 3 for the new x-coordinate of point S. And do the same thing for the rise. 4 minus 0 is going to give me 4. Take that and multiply by the ratio, you get a 1. I'll add that 1 to the initial y-coordinate of 0 from point A, and you still have 1. Okay, so y has y-coordinate, S has y-coordinate 1. So together, S has the coordinate 3, 1. Next, find the coordinates of point V that divides the directed line segment from M24 to C510, and partitions the segment into 2 parts with the ratios 3 to 2. Okay, so one part is 3, one part is 2. Together they make 5. So our ratio is 3 over 5. M is the initial, C is the terminal, because we're going from M to C. So do your terminal minus initial to find your rise and run. 5 minus 2 is 3. Take that 3, multiply by the 3/5. Okay, 3 times 3/5. That comes out to give me 1.8 in my calculator. I didn't want to deal with a fraction, so I just made it a decimal. Okay, we're going to take that 1.8, add it to our x-coordinate of our initial point M, so it's 2. 1.8 plus 2 gives me 3.8, and that's my x-coordinate of this point B we're trying to use. For the rise, you do your 10 minus your 4, you get 6. Multiply that by the 3/5. In my calculator, I get 3.6. Add that to the 4 from M, and you get the 7.6 for the new point, the y-coordinate of B. So B has coordinates 3.8, 7.6. Next, for each pair of ordered pairs x and y, find the coordinates of a point that lies 3/4 of the way from x to y. Okay, from x to y, it's the point is going to be 3/4 along the way, meaning I go 3/4 of the way there. So 4 represents the whole entire segment. I'm only going 3 of those 4 parts to get to my point I want to be. So this is a part to whole ratio already. Okay, so our ratio is not going to change. We're just doing the steps 2 and 3 over and over and over again, okay? So, ratio 3/4, yes. Run 20 minus 0 is 20. Multiply by the ratio of 3/4 to get 15. Add that 15 to the initial x. X is 15. Rise, similarly, 20 minus 0, 28. Multiply that by the ratio of 3/4. You get 21, I think, yes. And add that to the 0, of course, it's going to be 21. So my coordinate that's 3/4 along the way is 15, 21. The run, 13 minus 5 for B. You get 8. 25 minus 1 will give me the rise, okay? But we're not doing that yet. 13 minus 5 is 8. Multiplied by the ratio of 3/4. 8 divided by 4 is 2 times 3 is 6. 6 plus 5, which is the x-coordinate of x, is 11. That's my new x-coordinate. Rise, 25 minus 1 is 24. 24 times 3/4 is 18. Add that 18 to the 1 from x, and you get that the y-coordinate of the new point is 19. So my coordinate has 11, 19. Next, run 2 minus 10, negative 8. Multiply that negative 8 times 3/4. Negative 8 divided by 4 is negative 2 times 3 is negative 6. Negative 6 plus 10 will give me 4. It's my new x-coordinate. The rise, negative 3 minus 1 is a negative 4. Multiplied by the ratio. The 4's cancel and you're left with a negative 3. That negative 3 plus the y-coordinate is going to be, of 1 is now negative 2. So my new coordinate is 4, negative 2. Cool beans, last one here. Run. 11 minus 5 is 6. Multiplied by the 3/4, it's not going to be a pretty number. Calculator it gives me 4.5. 4.5 plus 5, which is my x, gives me 9.5 for my new x. And for the rise, negative 18 minus 3 is negative 18 minus negative 3, so it's negative 18 plus 3 is negative 15. Multiply by the 3/4, you get a negative 11.25, and then add that to the negative 3, you get negative 14.25. And that's my new coordinate is 9.5, negative 14.25. Whew. Oh my gosh, I did not finish this, I just noticed. Oh god. Here we go. Please forgive me. I thought I had. Or anyway, let's do it then, okay? Points x, t, and y are on a line segment. Which of the following statements is not correct? Okay, let's see. T, let's look at the first one. T is 60% of the distance from x to y. Alright? So look at our ratio. My whole part is 5 parts total, correct? Okay, from x to t is 3. 3 over 5, what is that? Let's put that in my calculator. 3 divided by, I want to get a decimal for that. That's 0.6. So that represents 60% as a percentage. So that is correct. So we're looking for the one that's not correct. That is a correct statement, a true statement. So we're going to mark that one out. The ratio tx to ty, they say is 3 to 2, and yes, that is correct. This is 3. This is 2. The ratio of tx to xy is 3 to 5. Ratio of tx to ty is 3 to 2. That's right. Okay. How about ty to xy? Oh, almost got me here. Almost got me. Ty has ratio 2 as part 2. Xy total is 5. This instead of 3 to 5 would be 2 to 5. So that is not correct, and that's our answer. Okay. Number 20. A man in a tower spots 3 hot air balloons flying at the same altitude. The red balloon is 5 miles east and 9 miles south of the tower. Okay. So red, call it R, is 5 miles east. East is to the right, so it's a positive number, so that would be 5. Remember, east and west represent the x coordinates. 8 miles south means I'm going down 8, so it's negative 8. Okay, that's my red, or R. The blue balloon, call it B, is 7 miles west. So that's going to be west is to the left, so that'd be -7. 10 miles north, 10 miles up would be +10. Alright, there we go. If the green balloon is located 4/9 the distance from the red to the blue. So we're going from red to blue. So red is my R is my initial, B is my terminal. Okay. So it's the green balloon is located 4/9 the distance. So my ratio is 4/9. We're going to find the location of the green balloon relative to the tower. We say this relative to the tower, that just means the tower is said to have the coordinates 0, 0, right? It's what we're relative of, so anything north, that's essentially, that's the only reason they say that like that, okay? We're just doing the same thing we've been doing. So the run is going to be -7 minus 5, which is -12. We take our -12, multiply by our ratio of 4/9. I'm going to do that in my calculator. I get approximately -16/3. That's a repeating decimal. I don't like repeating decimals at all. So I'm going to leave it as a fraction, -16/3. Okay? Then we take that -16/3. Add that to my initial x. This is great. Let me make sure I'm doing everything right. -5 minus 7. Alright. -7 minus 5, I mean. Yes. Okay, good. Just making sure. Sometimes I always get weird when I have these terrible things, terrible different numbers. Anyway, -16/3 plus 5. I'm just going to take that in my calculator, let it do it for me. I get that is equal to -1/3. Okay? That's my new x coordinate. Alright, I'm going to do a rise. So we do 10 minus a -8, so it's 10 plus 8, which is 18. 18 times 4/9. Oh, this should be better. Very good. 18 divided by 9 is 2, times 4 is 8. Wonderful. So we take that 8, add to the initial y, which is -8, and we're at 0. So that tells me that the green balloon is a third of a mile. It's a third of a mile, and the negative would be west, right? Yes. Of the tower. That's it, right? We're no north, so I don't need to say 0 miles north. All it is a third of a mile west of the tower. Awesome. Alright, last one. This has been a longer video than I thought it would be. At the amusement park, the Ferris wheel is located 9 miles east and 156 feet north of the entrance. Okay, so Ferris wheel F equals 95 east, which east is positive, because it's to the right, and 156 is also positive because it's up north. The roller coaster is located 23 feet west. 23 is negative because it's west, and 124 feet north of the entrance. If Mr. Puffy Pants the clown is standing exactly 3/8 the distance from the Ferris wheel to the roller coaster, okay, so our ratio is 3/8. Should be eighths. I can't type. The distance. To the nearest hundredth of a foot, find the direct distance between Mr. Puffy Pants and the entrance. Let's do this with these big numbers. We got this, okay? I run. This is going to be my. So let's see. 3/8 of the distance from the Ferris wheel to the roller coaster. So we're going from F to R. So my run will be -23 minus the 95. I'm going to do that in my calculator to get the -118. Take the -118, multiplied by the ratio of 3/8. Again, do that in my calculator. I get, okay, negative 44.25. Now we take that negative 44.25, add that to I initial x, which is 95, and I get 50.75. That's positive, so it's that many, so it's west. No, it's east. So it's feet east. Alright, my rise. Okay, we'll take the 124 minus the 156. It just tells me I'm going farther away from the entrance, right? 124 minus 156 is just a negative 32. Take that negative 32, multiplied by the ratio of 3/8. The 32 divided by 8 is 4. We have, and then that negative times the negative 4 times 3 is negative 12. Alright, let me take that negative 12, add it to the initial y of 156. Actually, no, this is, I'm getting close to the entry. Excuse me. Anyway, we're adding. Excuse me. Negative 12 plus 156. So negative 12 plus 156. 144. So this is feet north because it's positive. So Mr. Puffy Pants is 50.75 feet east and 144 feet north of entrance. And boom, I'm done. This has been a long video of 42 minutes. I'm at 42 now, almost 30 seconds. I'm going to quit. Email me if you have any questions. I'm going to send a reminder out late. I'm sorry if I wake you up. Have a good night and have a great time watching this almost 45-minute video.